Can the moon shine brighter than the sun? To most of you, the answer is no. But you might be surprised, as some scientists have revealed some speculations that the moon might be shining brighter. But how is this possible? Stay tuned, as in today's video, we are going to look at why the moon might be shining brighter than the sun. The electromagnetic spectrum. The sun is, without a shadow of a doubt, the brightest and most noticeable source of light in the sky. Right? Well, this might be the case, but it also could not be the case depending on how you define light. When we talk about light, we are typically referring to visible light, which is the type of light that we are able to detect with our eyes. However, the electromagnetic spectrum is extremely wide, and the visible section of the light spectrum, which spans from ultraviolet to infrared, is just a very small piece of it. This type of electromagnetic radiation encompasses a wide range of wavelengths and frequencies, including radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. The human visual system is limited in its ability to detect just a small portion of the full spectrum of light's wavelengths and energy. Colors are nothing more than changes in these quantities. Why the sun is brighter? Only for this reason do we even bother to build telescopes. Using detectors that are sensitive to these various forms of light, we may learn more about the cosmos at these varied wavelengths and uncover objects and energy sources that would otherwise go undiscovered. This is because these detectors are sensitive to specific forms of light. When it comes to these particular wavelengths, the sun is, for the most part, the force that predominates in the electromagnetic spectrum. But why? Simply because of how near it is to us. The sun is the most prominent object in the sky. However, there are many objects that are brighter and have more energy, but they are located at a much greater distance. Even though the sun is closer to us, the moon is even closer to us than the sun. But in visible light, the sun is roughly 200,000 times brighter than the moon. On the other hand, when you examine gamma rays, you'll see something very different. The gamma rays. Gamma rays are at the very top of the spectrum in terms of the amount of energy they emit, yet they cover a very broad range. They have an energy of around 1 million electron volts, which is sometimes referred to as a megaelectron volt. And since gamma rays are unable to get through the Earth's atmosphere, astronomers must utilize space telescopes to search for them in the universe. The Fermi Gamma Ray Space Telescope is a very advanced observatory that has the ability to monitor high-energy photons and even tags them depending on the amount of time and energy that is received by each individual photon. The moon is occasionally included as a significant component of the observation region that Fermi covers. After compiling all of the gamma ray observations from the moon, with an energy greater than 30 mega-electron volt, astronomers came to the conclusion that the moon shines brighter than the sun at these energies. The moon is nothing more than a gigantic ancient rock floating in space, since it lacks a magnetic field and surely does not have enough energy to emit gamma rays. Then why are they even here? These rays come from the universe, and when they approach their destination, they smash onto the surface of the moon. Atomic nuclei on the lunar surface become agitated when this quantity of energy is deposited, and they discharge this excitement in the form of gamma rays. When looking at far higher energy gamma rays, such as those with an excess of 1 gigaelectron volt, the sun once again supersedes the moon as the dominant body. Cosmic rays are currently wreaking havoc on the solar atmosphere, which is being subjected to their full force. Even while the magnetic field of the sun is powerful enough to protect it from some types of cosmic rays, higher energy gamma rays are still able to penetrate its surface. At least from our vantage point, the sun usually emerges victorious from conflicts of this nature. There are times when the moon illuminates the night sky like a bright beacon. Only a small section of the electromagnetic spectrum is represented by the rainbow spectrum of visible light that we are familiar with. It is possible to find infrared rays, microwaves, and radio waves beyond the red end of the rainbow. The truth behind Hulk. For sci-fi fans, gamma rays do not have a green coloration, in contrast to the Incredible Hulk. There is no way to determine the color of gamma because it is located outside of the visible range. So, how do humans react to gamma radiation? In the Marvel Comics universe, Bruce Banner is best known as the Hulk. The origin of the Hulk has been explained in a number of different ways. But one theory is that Bruce Banner's DNA was changed by an excessive dose of gamma rays, which in turn caused him to transform into the Hulk anytime he became angry. So, is it safe to be in an environment where gamma rays are present? Perhaps on the pages of a comic book or in a good sci-fi movie, but never in real life. The manner in which Bruce Banner is able to endure his transformation is not clear, since extremely high doses of gamma rays, similar to extremely high doses of X-rays, are often lethal to the average person. Gamma rays have the potential to displace electrons in a manner similar to that of a bowling ball. As a result of these charged particles shatter in chemical bonds, the delicate chemical machinery of the cell is destroyed, and molecule fragments are produced that have the potential to act as toxins. Effects of gamma rays. The gamma knife is a piece of medical equipment that directs gamma rays into a patient's brain in order to treat cancer patients. This method has been shown to be effective in the elimination of tumors. When Bruce Banner changes into the Incredible Hulk, muscles develop on his body, seemingly out of nowhere. Gamma rays have the capability of being so powerful that they can generate matter all by themselves if given enough time. Einstein showed that energy might be converted into matter and vice versa. This is the reason why this is possible. Extremely high-energy gamma rays, such as those produced by black holes, are capable of producing electron pairs, as well as their antimatter counterparts, which are known as positrons. Whether or if the Incredible Hulk breaks the principle of the conservation of matter and becomes larger by exposing himself to gamma rays is a completely different question. Since the beginning of time, the human race has been fascinated with space and spaceflight. Understanding the lunar environment has taken on a new level of importance in view of NASA's goal of transporting humans to the moon by 2024 as part of the Artemis mission. As a result of the recent discoveries, it is clear that astronauts who travel to the moon will require protection from the cosmic rays that are responsible for producing high-energy gamma radiation. How the moon shines brighter. So, how exactly do gamma rays cause the moon's surface to shine? Magnetic fields exert a considerable influence on the particles due to the electrical charges that are carried by the particles. On the other hand, because the moon does not possess a magnetic field, even cosmic rays with a low energy level are able to reach its surface. When cosmic rays collide with the surface of the moon, a chain reaction occurs that results in the emission of gamma rays. The moon is able to absorb the vast majority of these gamma rays, although it does allow some of them to escape. You might ask, why does the moon appear to shine more brilliantly in the photographs if the sun is the source of the gamma rays? We are unable to determine how much brighter the sun actually appears in telescopes' gamma rays due to the fact that we can only view the gamma ray light of the sun and the moon through the filter of our telescope. This is the case even though the sun actually has an energy level that is higher than 1 billion electron volts. This phenomenon is analyzed and explained by NASA. According to this theory, this is the case because the sun's enormous magnetic field deflects cosmic rays of lower energies. However, Fermi does not pick up all of the gamma radiation that comes from the sun. And that's all for today's video. What are your thoughts about the moon shining brighter than the sun? Let us know in the comment section below, and go through the channel for more videos like this. Thank you so much for watching. Until next time.